A equals pi r cubed. We need to find A when r is 1.3. We need to rearrange for r, this formula, and work out when A is 67 what the value of R is. We've also got a few examples which we're going to come on to that I didn't manage to cover in the previous section, so I'll do them at the end of this question, those last three examples in the notes. I've just kept up the sort of things we can do to equations here by way of reference. So we can flip it through the equals an object, move it across. We have to flip the sign. We have to do the same thing onto both sides. So whatever we do to this side, we must do to this side. That's another rule. And also we can move from divide to times and vice versa, or from times on one side to divide on the other side. So it's the whole side we're talking about. Okay, these things will become clear when we do the examples anyway. So let's have a look at this then. So the first part, A equals pi r cubed. R cubed, and R is the input value of 1.3. So pi times 1.3 cubed, wasn't it? Power 3. 6.90. Oh, it's squared. I've written down the formula wrong, so let me just change that then. I'll change it here first. I've just looked at the question, and we get 5.31 to 2dp. 5.31, and I'll just change these to squareds. Pi r squared, which is what it should be, of course, and that's units squared to 2dp. Right, rearrange for r then. So we'll move the pi, which is times on this side, to divide on the other side, but I'll write it down from right to left. So pi r squared then is equal to a over pi. Now we'll square root both sides. Square root something squared, you undo the square, and then it's the square root of a over pi. So we'll square root of this side. When you undo a square, square root is power half. Power you times, you get back to your original object, power 1. 2 times half is 1. So to undo a square, you square root. To undo a cube, you cube root, power third, and so on. So that's why we did that. To undo the square, we square root. And the square root of this side must equal the square root of that side. The same to both sides, wasn't it? So we've got the square root of a. A is the value 67. So it's the square root of 67 then, divided by pi. It's all inside the square root bracket. So that equals 4.62. That would be units, wouldn't it? Because r is a measure of the radius. So let's have a quick look at these then. Hopefully I'll get through some of them. Okay. So this one, these last three examples in the notes, have a quick look at them now. So rearrange for L then. Okay, so the first thing is to move this to underneath. T over 2 pi will equal the square root of L over G. Now the square root is power half. So if we now I'm going to square both sides, so I'm going to do it in one fell swoop. The square of that side will equal the square of this side. To undo a square root, you square. Power you times. 2 times half is 1, so that's why we did it. We've got L over G. And now we just move the G up. So that tells us then that L is equal to G times T over 2 pi squared. Which you could expand this bracket and tidy it up if you wanted, but I'm okay with that. And now we can put in the values. So it's G, which is presumably 9.81, yeah. So it's 9.81 times bracket T, which is 1.64, divided by, I'm going to put another bracket for 2 times pi, because I like to do that, just to be absolutely clear. Close the 2 times bracket, then close the T over 2 pi bracket, and that was squared, wasn't it? Equals 0.67. And that was to 2dp. Okay, that was that one. Now we move on to the other two. So I'll just move this out of the way here. We'll have a look at this one. So we need to rearrange for H, V and M. Okay, good. So rearranging for H, let's move this half mv squared over. So E minus half mv squared will equal the mgh. I prefer to write it down from right to left, so I'm going to do that. So E minus this is equal to mgh, so mgh is equal to that then. And then move the mg from times on this side to divide on the other side to get h. So it's E minus a half mv squared over mg, which we've moved down to divide. Okay, that was the first one. Now we arrange for v, so we'll move the mgh over now, so we've got half mv squared is equal to E minus mgh. Now this half mv squared you can write if you want to, so that it's unambiguous. If you're it's mv squared over 2, that's what you mean when you mean half or something. So we can clearly see to move the 2 up then, leave the v squared as is. 2 lots from divide to times, E minus mgh. So I move that from divide to times. I'm going to at the same time move this from times to divide, save writing another line. So that would be over m, wouldn't it? To undo a square, we square root. So it would be the square root of this stuff here. And you can put the m at the front with a 2. 2 over m, E minus mgh. That's fine. And it's the square root of the whole thing, of course. So I'll put a little bracket to emphasize that. Now rearrange for m. Now if you see here, there's an m common in a bracket. So let's take that out. E is equal to m. Then it would be gh in the bracket plus half b squared. And now it's easy to see that we can move the bracket down from times to divide. E over gh plus half b squared. So I've just moved that down underneath. So we've rearranged that. I think it was only 2 parts actually. I don't think I needed to rearrange for m, did I? In the problem? Yeah, m as well. Okay, good. So last part then, number 8. Let's have a look at this. So I'm going to move this, get rid of this and move that back up now. So all this can go. So we've done that. And now I'm going to move this back up. Okay, so we need to rearrange for y. No, work out y when x is 3, I think is what they want us to do here. So y is equal to, when x is 3, 3 plus 4 is 7, over 3 plus 2 is 5. I think I've written down the formula wrong as well in the problem. Let me just have a quick check. The problem, x plus 4, x minus 2 it is, so I've misread that. So it wouldn't be 5, would it? It would be 3 minus 2 is 1. 7 over 1 is 7. So that's good. Now let's do the next part. Now rearrange for x. So here, this object we can move up to the top. So x minus 2 times y is equal to x plus 4. We need to collect all the x's together. So let's expand this bracket then. So we get xy minus 2y equals x plus 4. Now I'm going to move this x over to be with that x. Xy minus x is equal to the 4. Leave the 4 as is, leave the xy as is, and I've moved this over. And I'm also going to move that over there to become plus 2y. Now I've got an x common here. Let's extract it outside a bracket. Get the y minus 1 inside, don't we? 4 plus 2y. And then we can move, lastly, we've got the x now outside. We can move this down. 4 plus 2y over y minus 1. And when y is 2, we get 4 plus 2 2's are 4 over 2 minus 1 is 1. So y equals the value 8.